up to today. Just to give you a brief understanding and a brief recovery to all what we saw so far, just to make you understand what we are about, and we'll proceed smoothly. Remember that we started with presented the technology behind securing the SQL Server based data manipulation. We presented the architecture that the SQL Server is built on. We talked about the tier architecture. SQL Server based on a client-server architecture. That's unit number 1. We're discussing the APIs. We presented the SSDT, the SSMS, the Visual Studio. All of them, they are .NET enhancing technologies, interfaces. They are giving us the chance to interact with the SQL Server and backend. We are able to reach, either to submit or to retrieve, or to manage even the data inside the SQL Server remotely. Absolutely. We defined unit number 2. We defined the T-SQL as a technology enhancing the build-up of transactions. Whenever we submit a query or retrieve data, also submit a query to retrieve data from a back-end solution. So we talk about an architecture. Actually, the T-SQL enhances the way how to secure those transactions via the implementation of different rules, accordingly depending on the transaction in question, on the task to do, and so on. Unit 3, we were talking about the definition of the stored procedures, and specifically we talk about the common language runtime procedures, which are back-end solutions. Actually, they are not unique, but it was discussing this SQL CLRS stored procedures as per the interaction with the front-end user-defined procedures or user-defined functions, mainly, yes. Means we are through the unit number 3, we are able to create the back-end stored procedures, nominated common language runtime procedures. They are procedures to be generated, stored inside the SQL Server, and then after executed accordingly, whether from the SQL Server itself or by a call through a user-defined procedure or a user-defined function from the front-end API, the SSMS or SSDT or the Visual Studio or any similar .NET enhancing API. Ahmed Jabri, I need you to repeat what I said right now. I need you to repeat the short prescription of those 3 units. Can you do, please? I will discussing, and I'm asking you, Ahmed Jabri, or any one of you, just the 3 units we passed through so far. It's a small briefing. What are they about? Aya, can you do? Lamia, can you do? Three units. Yes, I repeat, Hassan. I was saying what I was discussing now. It's a briefing about the 3 units we studied so far. Chapter number 1, chapter number 2, and 3. SSDT, chapter number 1. T-SQL, chapter number 2. CLRSP, chapter number 3. What is the node? What is the no? I'm not kidding here. Small briefing, which I just exactly what I presented to you now. I wasted 5 minutes to make you remember exactly what we finished, what we accomplished. Last class, you passed the midterm. It is only what I'm asking you to do now. What were the main contents, the definitions, the purpose of the 3 units we covered so far? The outcome, what is it? What are the 3 topics, the 3 outcomes we covered so far? Don't push me to just put you in a red list. The 10 marks, I can give 0 for all of you now without any hesitation. The question is clear. I'll submit it in the chat here to be recorded, and they need an answer from you somehow. Register this question, please. Let's start the unit number 4. Sorry. Still talking about the security purpose behind building transaction on the SQL Server. The transactions is not new to us since the unit number 2 were defined to us the T-SQL, and the T-SQL is a transaction-based let's say methodology, technology way of making the TS communicate with the SQL Server. So the transaction is not new to us. Yet we are going to present the security feature clearly. We are talking about defining what is a transaction based on the conformity to specific properties, conformity to the security view, whether it's secured or not. Now, because of the properties we're going to see and we're going to define the ways how we implement transactions. It's not the transaction itself, it's not the syntax. We define that as unit number 2 also. But here, properties to specify the high standard or the quality of the transactions. We'll be able to answer any question related to if a transaction is secured or not. We'll be able to say yes and no and why. We can prove that. In addition to that, we see other necessary tasks, activities, commands to make a transaction be fulfilled and to guarantee that data transmitted to a database or received from a database is ensured, true and correct, intact, exactly like it has to be. So this is exactly what this unit number 4 would cover. It's not long. It's intact and neat and clear, and it's brief enough to bring the technology like it has to be. Properties via which we start defining what is a transaction are 4 mainly standing behind the shortcut: asset, atomicity, consistency, isolation, and durability. Asset, ACID, asset. So we talk about the conformity to the asset properties. A transaction has to be defined based to the conformity to the asset properties. The asset is a group of 4 properties that define how a transaction is built. It has to be conformed to those 4 properties in order to say that the transaction is fulfilled, secured, and ensured in the data. Okay. Behind of the building of the transaction and talking about the conformity to the asset properties, there is an architecture that we are insisting on. The architecture, we know it since unit number 1 when we talked about the APIs, that they are the tools we utilize, or the developers utilize to interact with the SQL Server instances. So the security here actually it is an architecture base. It is an architectural view of the it is security based on the architecture somehow. In addition to the secure code, in addition to what we saw through the implementation of the transactions in unit number 2, the T-SQL, also what we're going to see still is enhancing the secure code. Means the solution we're going to solve, any query we're going to build, we can implement it differently by simply passing the SQL query respectively to a specific insert or a select or update or whatever, any DMF or even a DDL. We are going to talk about a higher secure, let's say, queries, or let's say transactions literally. So we are going to continue the same line, present the security via the architecture of the project system. And what we are going to see, actually, it enhances the terminology, secure coding. There are terminology that we're going to define step by step in this unit also, related to the transaction security, conformity and isolation. We see them. First definition we are going to discuss is to define what is a transaction. Briefly, a transaction is data retrieval or data or a query to be submitted to the SQL Server from the front end API that the user is utilizing, the end user is utilizing. This is the sort of a technical definition. But let's take an example to make you understand more. Actually, we have a group of activities that we are going to implement and going to make the system understand. See, I'm going to read those 3 phrases, and we have to make the computer understand them. In a renting agency, car rental agency, somebody goes to and selects a car to rent. Then he confirms the payment. Yes, he's going to take it, and then after he takes it, dials it and goes off. So this is a process. It's a sequential process. This sequential process has to be presented to the computer in a way to make the computer understand the sequence. Actually, the computer does not understand what is the car. It will understand an object representing the car. And the computer does not understand the order, first, second, third. He will recognize the sequence that an object has to be manipulated, and the result or the return has to be passed to the second, let's say, activity. Then the second activity outcome has to pass to the third, let's say, process or activity. Thus, there is a sequence that the computer has to understand. This is what actually the asset, the atomicity, consistency, isolation, and durability would present to us, to define perfectly and clearly what is the transaction. So, to understand what is asset, those properties, those 4 properties that the transaction has to be built on, means when we say that the transaction is fulfilled, a transaction is secured, The transaction is exactly doing what it has to do. If it is conform to the asset properties. Asset, I repeat, atomicity, consistency, isolation, and durability. Those are properties that each of them, one by one, the four, they have to be actually fulfilled by any transaction you talk about, any transaction you set, or transaction you use. If they are not conform, you may get an output. Still, means if I ask you in a question in an exam, saying that a non-conform transaction to the asset properties can produce an outcome or can display a result. The answer is true, because it's not the context of bringing an outcome or getting an outcome, because select or insert can be done straightforward with passing the query to the SQL Server. Select star from or insert into table. Straightforward. Thus, if those four properties they are not respected by a transaction, still the transaction can give an outcome. Yet, what is the problem if they are not conform? We are talking about the capability of losing the data, which is the insurance. The data, if it's not fully transmitted to the server, there is a problem. In the sense of the data, if it has not been submitted fully to the server, the backend solution, the backend this way, we have to set up those properties to identify the quality of the transaction. Quality here covers the security, covers that it has to be committed, it has to be transmitted the data with an intact state, not to be altered, not to be intercepted, and so on. So those statuses, the qualitative transaction, it is to be guaranteed by the asset. This way, let's start with defining what are the those four properties one by one. Taking the example of the ATM transactions. ATM transactions.
تمام على العموم زين موفقين وفي زياره بس شيء منير على بعدين تواصلنا بعد عده اسابيع.
Somebody goes to the ATM machine, presents himself, identifies himself by just putting the ATM to the machine. The machine recognizes that the card is intact, is accepted. Then he requests an amount. The amount is validated. Then after the, let's say the amount has been given to him, then finally the account is updated. Means whatever he retrieved, whatever he withdrew, the account will be deducted that amount. If he withdraw 10 riyal, 10 riyal would be deducted from his account. So this is the process. Good. The atomicity here actually, it's a context of guaranteeing that those steps has to be fulfilled. Why? Because let me tell you one scenario. He goes to the ATM machine. He presents himself, identified, withdraws the money. Okay, asks for 10 riyal. The 10 riyal has been given to him. At that position, exactly, and at that time exactly, the electricity shuts down. What does it mean? The server has stopped. The machine has stopped. What is the problem? The problem is the last step, the update, to take off the amount he withdrawn from his account. Means the machine has given him 10 riyal, and still it has to update his account. It has to deduct the 10 riyal from his account. There were a problem to make the machine run fine, which is electricity cut or shortcut. So what's the solution here? There have to be scenario. There have to make a scenario to make the machine not to give him the money unless to do the totality of the tasks, which is to identify the user, to recognize the account, the balance, whatever the amount he asks, and to confirm the update, and to give also the money. All of those tasks, they have either to be done altogether or to fail altogether. Conclusion here means a transaction either the group of transactions to be executed altogether or fail altogether. It's not okay to give money and not to update the account. It's not okay to deduct the amount from the account without giving money to the agent. It's not okay. So the asset comes in action here. Good. The first review is to see the group of actions as one task. Checking the balance. Yes, you have enough money. You as an agent, give you the money. Then update your account. Check your account, is your ID. Then check the balance. I ask for 10 riyal. I have to have 10 riyal in my account. If I don't have, it will not give me. So it has to check the account, balance account. Then checked, it has to give you the money. 3. Then 4, it has to update the account. Since you don't withdrawn, since you took the money, it has to be deducted from your account. They have all to be executed. They have to be all executed. So all of them, they are atomic. All of those tasks here, they are atomic. They are one task. They are one transaction. Meaning the transaction has 4 commands. Either they have to be executed the full or fail the full. Means we cannot execute part of them and neglect the other. No, it's dangerous and not accepted at all. This is an example only, the ATM machine. No more, no less. The first property is the atomicity. And we now understand what is the fact of being atomic. The second property is the consistency. Actually, the order here, we are defining them as per the order, but the properties, they have to be set all together. There is no order when we make a conformity of those properties on a given transaction. Yeah. The consistency is that we are not talking about the tasks as to be atomic or not, but we see them again that they are atomic here. A transaction, for example, of withdrawing the money, it will take, for example, 1 minute, 1 minute of time. It has to be fulfilled fully. We do not have to rectify the time or just shorten the path for a reason or another. The consistency here, either to fully finalize the task or not. If an electricity shortcut happens in between, for example, at the second 30, after 30 seconds, shortcut happens. Still, the transaction is going. The full transaction has to be failed, not half. Now, we are not talking about how many queries to do inside the transaction. No, we are seeing the transaction as one unit, as an atomic. Means one just transaction to do. However, the number is of queries inside this transaction. We have, like in this example here, 4. Check the ID, check the account, withdraw, and update. Let me change the colors. You check the account, check the balance, withdraw, and update. Those are 4 tasks that they have to be actually either executed altogether or fail altogether. They have to be seen atomic. Good. The consistency, those 4 which are one transaction, they are formed in one transaction, they have to be executed during the full transaction path. Actually, you talk about time without any failure. If any reason causes that those or this transaction, this single transaction happens to fail in between, the full actions inside the transaction has to fail. Means in this example, the 4 commands, the 4 requests here have to fail. We don't say that half of them execute, okay, let them, okay. No. Either all or no. This is the consistency. All from the beginning until the end of the transaction, they have to be actually fulfilled, all the steps, all the queries. Or no. We talk about consistency. Means, in case of, if, for example, in the case here, as per the example I given you, the transaction, the ATM withdrawal action would take, for example, 1 minute. If at the 30 seconds, after the half of the time passed, an electrical shortcut has happened. Means the current has shortcut for a reason or another. Means the transaction is not finished. So everything in the account has to be not altered. The initial identified account has to be non-altered. Means it has to be rolled back. Everything has to be rolled back. The system has to roll back everything as it was. The half transactions that he started to do, he has to roll back. He who is the system. The system has to roll all the activities that he reaches to accomplish before the problem happens, to roll them back. Any questions here, please? Here, actually, talk about the consistency. It's consistent. It means the system will recognize that the finished transactions, admitted, or the unfinished transactions will cause to roll back everything. This is consistency. So the transaction has to be consistent. Any questions, please, here? Okay, great. We proceed. No, okay, great. No, Ala, no. Okay, great. The third property is the isolation here, in the sense of let's talk about the same example, which is the ATM machine transaction, we are going to withdraw the money. For example, the same bank, let's take the example of this, not of any bank. Actually, the majority of the banks, they have more than one machine working during night time. Means if you go to withdraw money during the night, you'll find 2 or 3 or more ATM machines. There are possibilities also that other people would come at the same time, and they would use other machines with you, and they are all linked to the same provider, which is the same bank. Means from the same database, the system will check the account of you and of the other people at the same time. Means the system will be working on the same database tables or entities at the same time for different accounts, for different transactions. Is there any possibility to intercept, for example, your transaction to accomplish another person's transaction? This has not to happen. It is self-isolation. Means your transaction is atomic and consistent and not to be intercepted. Any other trials to intercept have to be blocked. Here it is. Any interception trial to stop your transaction and serve others has to be blocked. We are not talking about the interception as a security issue, the XSS or the injections. No, no, no. We are talking only to stop your transaction to serve others, to serve other transactions. No, it has not to be happening. For security reasons, a transaction has to be consistent without any interception, consistent and isolated. So the view of being isolated means a transaction, it has to be initially atomic, then it has to be consistent, that the system will recognize, that has to be actually executed, covering how many commands and what is the final state. Then he has to block all trials to execute other transactions at the same time by stopping your transaction or your commands. No, it has to. They have to be actually eliminated. I give you the examples of 2 different transactions. You are trying to withdraw money. Another person is trying to withdraw money from the same system, from the same database, from the same bank. No, completely no. So every transaction, your transaction has to be isolated, and the other person also has to be isolated. So the isolation is a fact. It's a property that has to be fulfilled with all transactions, not only yours. And the example of ATM withdraw, it's only a case because it has 4 commands to do inside. This is a good example to make you understand. So we cannot do, for example, the system cannot do, let me just come back one step. The system cannot do the checkup of your account and check how much you have, then stop here to serve person number 2. He goes to check his account and his balance, and he gives him money and he updates the account and comes back to you to check, to give you money and update your account. Never. Never. It has not to happen. Actually, technically, we can do. Technically, it might happen. For a reason or another, the system can stop your request, stop others, and come back to you. The system can do that. Yet, this is a breach. This is a fraud. This is a vulnerability. This is not accepted at all. For a reason or another, it can cause data leakage. So that's a transaction fully has to be seen atomic, consistent to be executed from the beginning till the end, without having given the chance for interceptions. or for intruders, external intruders. Isolation. The fourth property, the last, is the durability. What does it mean? With the same case, the ATM machine. Okay, the concept of the commands, they have to be atomic. Then the execution of the commands, since they are atomic, they have to be consistent. Means fully executed or fully failed. Roll back. Then isolated. No interceptions. No intruders in between. No interruption to your commands to serve others. Isolated. Hey, okay. This one actually, this behavior, it is actually to be happening during certain period of time. Means is it to be happening every day or just during the work days? Means on weekend we can break those rules. No, they have to be for usual. They have to be without any failure. Usually they have to be atomic. Usually they have to be consistent, and usually they have to be isolated. Durability without any limit, unless the system owner or the system developer or webmaster sets rules for specific interruptions. Otherwise, the rules, they have to be usually and for everybody. We do not say this is the bank, for example, the bank administrator. No, we give him an order, a priority. So all customers, they have to wait for the system to serve the bank administrator. No, completely not. Completely not to happen. So durability means the properties that a transaction has to be atomic, consistent, and isolated have to be all times happening, and with all privileges or privileged users available in the system. Either it's the current user, administrator, or a system user. All of them, they are to be obey to their transactions have to be atomic, their transactions have to be consistent, their transactions have to be isolated also. Durability. Any questions, please? If you have any questions, you may interrupt. Thank you very much. No. So let's talk a summary about the asset, a summary to make us summarize what we defined regarding the asset, the properties. A fact of being atomic means unless actually the final query or final command has been executed, the transaction has not to be considered finished or complete. So as per the example of the ATM machine, we have 4 commands. So the 4 commands have to be actually all together executed. They have to be seen all, not part of them. The system has to recognize that the transaction have 4 commands, for example. In this example only, we are talking ATM machine 4 commands, but we may find transactions with 10 commands, 100 commands, 1 command, whatever the number is. All the related commands in a one transaction, the system has to see them all. The system has to see them all as one. This is the atomicity. We're talking about atomic. So 1 unit. So the second property, the consistency, the system actually has to check out that the transaction either to be fully executed, and there are no, let's say, breakups. There is nothing to stop the execution in between. There is no rule. There is nothing to be broken. Means the transaction once started has to be finished. There is nothing to stop it. There is nothing to violate the execution of the transaction. Either to execute it or to leave it. Execute it fully or leave it fully. Isolation, it's a context of not letting external intruders intercept your transaction. Means the transaction once started, others cannot intercept your transaction. If a transaction has started, the system has to guarantee that the transaction property have to be guaranteeing that the transaction would not be intercepted and other transactions would be executed and given prioritized order. No, this is an isolation. Durability means actually the transaction is atomic usually, is consistent usually, and the isolation would be actually guaranteed usually. Whether the number of commands is small or big or whatever, anytime and for any session. What does it mean session? It means if I am a normal user, or I am an administrator, or I am a system even, a very high privileged user. For all cases, those properties, the consistency, atomicity, and isolation, have to be fulfilled all time. Durability. This actually happens for you whenever you come back to the system, whether it is the ATM as per declared here or any other system. So the scenario would happen typically the same as how it looked or how it was the first time. Whenever you use the same function, the transaction has to happen the same way. Durability. I come to an end. We continue next class, Sean. Do you have any questions, please?